In this video, we're going to find all possible roots of a third degree or higher function and use this list of possibilities to find a factor of the polynomial. We are going to accomplish this using the rational root theorem. Now, the rational root theorem tells you a list of possible rational roots for a given polynomial function. Now, I'd like to emphasize that it says it's a list of possible or potential rational roots. Now remember, roots are also called zeros, which are closely related to solutions. And by a rational root, we mean a root that's not a square root or something like that. Okay, so here's how the rational root theorem works. The possible rational roots equal the factors of the constant. Now by the constant, we're referring to the plain number at the end of the polynomial. In this case, the constant would be -3. So in the numerator, we have factors of the constant. In the denominators, we have factors of the lead coefficient, or the number in front of the x with the highest power. So in this case, the leading coefficient is 6. Now you may be asking yourself, why is this list of possible roots important? Well, when solving a third degree or higher equation, we often want to begin by factoring out a binomial. Knowing a root, also called a zero, can help us find a factor to divide out. So that's where we're headed here. We're trying to find a root to help us find a factor to divide out of the polynomial. And when we do that, we'll go from, say, a cubic polynomial to a quadratic polynomial. And that becomes much easier to work with. Let's dive in and take a look at some examples. Okay, so for now, we're just going to state the possible rational roots, or zeros. So we have a function here. Now in the numerator, we're going to have factors of the constant term. So let's find those first. So factors of, now you'll see in a second why we don't need to really worry about the sign at this point. The factors of the number 1 are positive and -1. Okay, nothing too earth-shattering there. Let's write a list now of the factors of the leading coefficient. So factors of 3. That will be, we'll see, the number 1 is a factor of 3. And 3 is a factor of 3, because nothing else divides into the number 3. All right, so it's time for us to figure out our possible roots. Now, one way of organizing this information is to just kind of draw a large fraction here, and we'll just put our possible factors of the constant term in the numerator. So in this case, that's just positive and -1. And then we'll put a list of the possible roots of the leading coefficient here in the denominator. And then we'll just kind of keep going from there. Let's keep simplifying this. So we'll go ahead and write positive and -1 over positive and -1. And we can simplify that as positive and -1 over 1. So that's this numerator over this numerator, this numerator over this denominator. Then I'll put a comma here, because there's more. Then we have positive and -1 over positive and -3. So that would be positive and -1/3. All right, we can simplify this 1 over 1 to complete our list. So the possible roots are positive and -1 and positive and -1/3. Now, this is not a list of the roots of this polynomial. It's a list of the possible roots of this polynomial. Let's try another example. So we'll start by listing out the factors of the constant term. So we have the factors of 11. Well, let's see, that would be positive and negative 1. And 11 is a prime number, so nothing divides into it besides 1 and itself. So that would be positive and negative 11. And then we want to list out the factors of the leading coefficient, the 2. So we need to figure out the factors of 2. 2 is a prime number also, so that makes it easy. So we have positive and negative 1, and positive and negative 2. That's the list of all the numbers that divide into 2. All right, now it's time to make a list of our possible roots. So one key thing to remember is that the factors of the constant term are in the numerator. Okay, so we have positive and negative 1 over 1, comma, positive and negative 1 over 2. And we'll go to the 11s here. So we have positive and negative 11 over positive or negative 1. So that would be positive or negative 11 over 1. And then we have positive or negative 11 over positive or negative 2. Let's go through and simplify that. This would be positive or negative 1, positive or negative 1/2, positive or negative 11, and positive or negative 11 over 2. This is a list of the possible or potential roots of this polynomial. This process is all a little bit mysterious, so let's try just a couple more examples to make sure we've got it. All right, then in the numerator of our list will be the factors of the constant term. Maybe we can start writing this a little bit differently. So we'll have the factors of 1 over the factors of 4. So just put our factors of 1 up here. So that'll be positive or negative 1. That's the only thing we could divide 1 by. Now the factors of 4, well, 1 divides into 4, 2 divides into 4, and 4 divides into 4. So we have positive and negative 1, positive and negative 2, and positive and negative 4. All right, let's go ahead and break that up into individual factors here. So we have positive and negative 1 over 1, comma, positive and negative 1 over 2, comma, and positive or negative 1 over 4. All right, those are all simplified. So there's our list of the possible roots of this polynomial. Okay, one more example. So we're going to need to find the factors of 5. And that'll be in the numerator, and the denominator will be the factors of 6. Right, the factors of 5. Well, 1 divides into 5, so that'll be positive or negative 1. And 5's prime, so the only other factor will be positive or negative 5. 6 is not prime. So let's think of all the numbers that divide into 6. Well, that'd be positive or negative 1. 2 divides into 6, so we have positive or negative 2. 3 divides into 6, so positive or negative 3. And then 6 divides into itself, so positive or negative 6. All right, this list is going to be longer, so let me start over here. All right, breaking this up into individual factors, we have 1 over 1, so that'd be positive or negative 1 over 1. Let's go ahead and simplify that. Positive or negative 1 over 1 would be positive or negative 1, comma. Let's keep doing all the possibilities with 1 in the numerator. So we have 1 over 2, so positive or negative 1 over 2. You have 1 over 3, so positive or negative 1/3. And then finally, positive or negative 1/6. Let's do all the possible roots containing this 5 in the numerator. So we have 5 over 1, so positive or negative 5. Then 5 over 2, so positive or negative 5 over 2. Then 5 over 3, so positive or negative 5 over 3. And then finally 5 over 6, so positive or negative 5 over 6. All right, that's quite a list. All right, let's use that to do something just a little bit different. This time we're going to find a factor of this polynomial. Now, the idea here is that we could hopefully find a binomial factor of this cubic polynomial, and then we could divide this polynomial by that factor to then have a quadratic polynomial. Once we have a quadratic polynomial, we'll have a lot more options to solve it. Okay, so before we can find a factor, let's find those possible zeros. All right, so we're going to need the factors of 16. That's the constant term. Could be the factors of negative 16, but that would be the exact same list. Let's keep it simple here. And in the denominator, we'll have the factors of 1. We like the sounds of that. We understand there's a 1 right there. Okay, the factors of 16. So the number 1 divides into 16, so positive or negative 1. We have positive or negative 2, because we can divide 16 by 2. We can also divide it by 4. And we can divide it by 8. And we can divide it by itself. So quite a few there. But fortunately, in the denominator, there's only positive or negative 1. So we have 1 over 1. So it's positive or negative 1. 2 over 1, so positive or negative 2. 4 over 1, so positive or negative 4. 8 over 1, so positive or negative 8. And finally, positive or negative 16. All right, this is a list of the possible roots. So for instance, if positive 1 is a root, x would equal 1. Now we don't know that. But we're trying to find factors. So let's turn this root into a factor. So if we subtract 1 on both sides, we get x minus 1 equals 0. All right, so that means the factor that goes along with a root or 0 of x equals 1, the factor would be x minus 1. So the factors related to positive or negative 1 are x minus 1 and x plus 1. The factors associated with this root here, these roots, are x minus 2 and x plus 2, and so on. All right, well, let's just start at the beginning. We'll try dividing this polynomial by x minus 1. Now we'll use synthetic division to do that. So I'm going to write the coefficients of this polynomial. So that'll be 1, negative 6, 16, and negative 16. Those are just these coefficients here and the constant. Make my little synthetic division bracket. And the 0 is 1, so that's what we put on the outside here. And we're checking to see if x minus 1 is a factor of this polynomial. All right, the first step is to bring down that 1, then we multiply. Then we add these. And we go back to multiplying. Negative 5 times 1. And we add. And then we multiply. All right, we got a remainder. So this 0 didn't work. So x minus 1 is not a factor. That was a fairly quick process, though. So let's go ahead and continue that. I'll write these same coefficients. I'm going to try another division problem here. Now, starting at the beginning, so now I'm checking to see if I can divide this polynomial by x plus 1. Well, the 0 related to that factor is negative 1. So now we'll just try dividing by negative 1. Bring down the 1 and multiply. We add those. And multiply. Negative 7 times negative 1. And we add those. And we multiply. And we get a remainder. So x plus 1 is not a factor of this polynomial. But let's keep going. Make a little room. Hopefully we don't have to go all the way to negative 16. Maybe it'll be one of these. All right, same coefficients. So I have 1, negative 6, 16, and negative 16. All right, let's try a 0 of 2. So this would be the factor x minus 2. Bring down that 1 and multiply. And we'll multiply. And multiply. And we get a remainder of 0. X equals 2 is a root, or 0, of this function. And the factor associated with that is x minus 2. So we just figured out that x minus 2 is a factor of this polynomial. So before our next video, you can be thinking about why knowing a factor of a cubic polynomial might be helpful. But until then, this is Mr. Ela, signing off.